Hello everybody, we'll continue with so this is what we have done regarding the descriptive statistics. So today we're going to continue with uh, the fitting of two distribution, normal distribution and student t distribution uh, to one theoretical simulated uh, series and also the MISE series. So for this part, let's say we want to have, we're going to simulate histogram fitting for return series. So we're going to generate a return series based on this. So the rest of this, maybe you can just we can just keep this. Okay, continue with the rest of it. So first of all, we're going to generate a returns with the value from so this is basically, let's say, from 0 to 0.1. So with the interval 0.1, now it's -7 to +7 to 7. So in this case, you can just have a plot and have a look at the box plot. You should be able to see from this diagram. So this value, negative should be close to -7, positive is close to 5, right? So in just for simplicity, we just use a value from -7 to +7, right? With interval 0.1. So you have -7, -6.8, -6.9, -6.8, and so on and so forth until 7.00. So after that, we're going to generate a normal distribution using the normal PDF. So this is the normal probability density function with the series here. So of course, the normal distribution is going to have two parameters, mu and sigma. So let's say mu is 0, sigma, let's say, is 1. So this is basically the standard normal distribution. Okay? And another distribution is called t distribution, okay? With a degree of freedom, let's say 5. Okay? So you can set the degree of freedom as you like. But normally, the financial data should have the financial return series is commonly to have 3 to 6 degree of freedom. So let's say you just put 5 here. So to generate the t distribution, so we use the t PDF. Right? So you need to include the series which is returned, and then the nu basically is the degree of freedom. Right? So let's say 5 for this case. Of course, you can estimate the value afterwards. Okay? So now we can do a plot on the value. So plot, you have x and y. So this is x, y will be y norm. Then another series is return and yt5. Alright, yt5. So for this, you can actually fit into the color you like, the options. Under the option, you can have, let's say, I want a dotted line, or pattern of a line is hyphen and then red color, let's say. Okay. So for for the other graph, let's say we want a different color, dotted line with blue color. Okay. So this one can be fixed. The line. So after that, as usual, we just put a title, normal, and t fitting. Okay. T return. Then we have a label of x. X is the returns basically, respect the time. And then y is the PDF. Types of probability density function, is it? And then we have a legend just to indicate the normal. So this is the first one. The second one is T with no equal to 5. Right? So that's it. So from here we can generate the fitting of these two distributions. So from this diagram you can see that a comparison between sorry, there's a typo here. Maybe I can just normal. Okay, just run this one more time. So you can see the blue color and the red color. So blue color is student T with degree of freedom 5. Red color is the standard normal distribution where 99.7% of the distribution will be fall within -3 to +3 range. Okay, but for student T with degree of freedom 5, you can see the tail is much heavier than the normal distribution. So therefore, student T also is known as the heavy tail distribution if compared to normal distribution. Okay, guys. So if you want something, let's say a higher degree of freedom, let's say here, let's say we generate another degree of freedom. Let's say 3 degree of freedom. So this is heavier. So now we just use the same value with degree of freedom 3 now. Right? So add in another color, return and YT3. So let's say we want, let's say just put in green color, doesn't matter. So here we have the third value will be t with no equivalent to 3. Okay, so we put 3 graph in together, then end up we have the green color basically is the degree of freedom 3, sorry. So it is even heavier than the degree of freedom 5. Okay, so in this way you can see more observation occurs in the tails of both tails. Okay, so this is symmetrical, looks like normal. Somehow the tail is controlled by the tail index, which is 5 and 3 like this case. Okay, okay, great. So this is what we have done for a simulated series. So in order to fit in the value of student T, I mean the NYSE, okay, then we can continue this with this one is histogram fitting. This is another one. Just copy and paste this for NYSE returns. Okay. So this one, first of all, we just use a function called histogram fit. Okay, we're going to fit the series. Of course, is a return NYSE. Okay, this is the series we have. Let's say the bin we can just put, let's say 50. Since we have 3,000 observation, I think bin 15 should be okay. So we use the distribution name. Of course, it's not beta, so distribution name we just put normal. Okay, or you can just go to here and look at histogram fit in the documentation. Then you can see that okay, histogram fit. So under this there are several quite numbers of distribution here. Okay, so you can have beta as the default value. So if you want the normal, log normal, then you just put normal. So for student T, is T location scale, is T location scale. So this is for T distribution. Okay, and all this distribution, if you think your empirical data is following any of these, then you can just name the possible or the specific distribution involved. Okay. Okay. So for this one, we can just close it. So this one, after this we have, okay, so this one maybe you just put a semicolon to reduce the weight. So the title basically this one is normal fitting, right? Normal fitting, normal histogram fitting. So another one, we want to have use the student T, exactly the same thing. Let's say we just put in another graph. So for student T distribution, we use just now the T location scale, isn't it? T location scale. So this is student T, student T, or students T, student T histogram. I think this is kind of this student T. Okay, something like this. So now we can have a look at the fitting of these two distributions. So go to run. This is not one. So this is two graphs. One is fitting the NYSE using normal, one is using student T. Okay. So this student T is actually estimated the mean and variance, okay, by the Matlab itself. So you can see the fitting for normal compared to the student T. Okay. So obviously, the normal fitting basically not able to capture all these extreme values after 3 standard deviation. Okay. But somehow the student T fit quite well even after -4, +4, isn't it? And the fitting is much more better than the normal distribution. So here we can make a quick conclusion that the student T distribution fit better than the normal distribution by looking at this histogram fitting, isn't it? Okay. Okay. So end this session here and see you guys afterwards. Bye bye.